Therefore, the series is f of x equal to 40 plus 58 into x minus 2 plus 38 into 53 53 plus 38 x minus 2 whole square by 2 factorial plus 12 x minus 3 x minus 2 whole cube by 2 factorial. So that is the required Taylor series expansion. Polynomial case so just leave it like this. Don't try to open up the brackets and simplify it. When we simplify again, we will get this polynomial again. So in case of polynomial, what we do is we are simply rewriting the function in powers of x minus 2. We are asked to find the Maclaurin expansion of this function. അപ്പോൾ Maclaurin series function x in the powers this is already in powers of x. So for any polynomial, the Maclaurin expansion of the polynomial will be itself. Okay. Look at the next problem. So next is expand sin x in powers of x minus pi by 2. So we have f of x equal to sin x. So f of pi by 2 will be equal to 1. So f dash of x is cos x. F dash of pi by 2 is going to be 0. F double dash of x is minus sin x. So f double dash of pi by 2 will be minus 1. Then f3 of x is minus cos x. So f3 of pi by 2 will be 0. And f4 of x is again sin x. So f4 of pi by 2 will be equal to 1. Now that will keep on repeating. So that is the sequence of values. So therefore sin x will be equal to, so you will get f of pi by 2 plus x minus pi by 2 into f dash of pi by 2 by 1 factorial plus x minus pi by 2 whole square by 2 factorial f double dash of pi by 2. So first term will be 1 plus second term 0 varum, third term minus 1 ആയിരിക്കും വരുന്നത്. Minus 1 x minus pi by 2 whole cube by whole square by 2 factorial. The next term is 0. Then you have 1 into x minus pi by 2 whole raised to 4 by 4 factorial. So the series is 1 minus x minus pi by 2 whole square by 2 factorial plus x minus pi by 2 whole raised to 4 by 4 factorial. Next term is going to be x minus pi by 2 whole power 6 by 6 factorial plus x. So that is the required series for sin x in powers of x minus pi by 2. Problem is to use Taylor's theorem to prove that tan inverse of x plus h is equal to tan inverse of x plus h sin z into sin z by 1 minus h sin z whole square into sin 2z by 2 plus etc. where z is given by cot inverse x. So here you have f of x plus h. So the given function is tan inverse of x. So f of x plus h is tan inverse of x plus h. So therefore f of x will be tan inverse of x. And ഇനി ചെയ്യുന്നതാണ്. So when you take f dash of x, so we will get 1 by 1 plus x square. Now we need for the Taylor series expansion, we need the derivatives of f of x. ഇനി f dash of x എന്ന് പറയുന്നത് 1 by 1 plus x square. ഇനി we have seen how to find the nth derivative of 1 by 1 plus x square. The rational function ആണ്. You can write it in the form a by x plus I plus b by x minus I. Then substitution കൊടുക്കുക. X equal to r cos theta and 1 equal to r sin theta. So we can obtain the expression for the nth derivative. അപ്പോൾ ഇതിനെ partial fractions ആയിട്ട് convert ചെയ്തിട്ട് n minus 1 times differentiate ചെയ്യുമ്പോൾ you will get the nth derivative. So I leave it to you finding that. So fn of x will be obtained as minus 1 all raised to n minus 1, n minus 1 factorial sin raised to nz into sin nz varum. So here z will be cot inverse of x. So x equal to polar form substitution കൊടുക്കുമ്പോൾ so we will get this expression. അതായത് imaginary part മാറ്റുക. So we need the nth derivative in real terms only. So this is the nth derivative. So here we have obtained the expression for fn of x. And now let us use fn value to write down the Taylor series expansion. Okay. So f of x plus h will be equal to f of x plus h by 1 factorial f dash of x plus x square by 2 factorial f double dash of x h cube by 3 factorial the derivative of x plus etc. So f of x is tan inverse of x plus h by 1 factorial. Now we have fn as minus 1 all raised to n minus 1, n minus 1 factorial sin power n z sin n z varum. So f dash of x is going to be equal to, that is when n is equal to 1. So we will get sin z whole square varum. Then the second term we have x square by 2 factorial f double dash of x is, that is when n equal to 2. So we will get minus 1 into 1 factorial sin square z into sin 2z varum plus h cube by 3 factorial. The third derivative is n equal to 3 varum 2 factorial sin cube z into sin 3z plus etc. So when you simplify, you will get tan inverse of x plus, okay, so you can write in the form h sin z into sin z by 1 minus, next term will be h sin z whole square varum. Me sin 2z by 2. The next term is plus h sin z whole cube. Then 3 factorial and 2 factorial cancel off, but we will get sin 3z by 3 plus etc. So that is the required expansion. Next problem is to prove that f of x square by 1 plus x equal to f of x minus x by 1 plus x into f dash plus x square by 1 plus x whole square f double dash of x plus etc. So here we have f of x square by 1 plus x. So this can be rewritten in the form f of x minus x by 1 plus x. So x minus x by 1 plus x is equal to x square by 1 plus x. Now this is in the form f of x plus h. So in place of h you are having minus x by 1 plus x. Okay, so now by Taylor's theorem, f of x plus h will be equal to f of x plus h by 1 factorial f dash of x plus x square by 2 factorial f double dash of x plus etc. So we need now h here h will be equal to minus x by 1 plus x. നമുക്ക് നേരിട്ട് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്താൽ മതി. We require in the standard form only f dash f double dash ഫോമിൽ തന്നെയാണ് നമുക്ക് പ്രൂവ് ചെയ്യേണ്ടത്. So just substitute the value of h here. So therefore f of x square by 1 plus x will be equal to f of x plus h by 1 factorial f dash of x plus x square by 2 factorial f double dash of x plus etc. So f of x വരും first term, then h will be minus x by 1 plus x f dash of x by 1 factorial, x square will be x square by 1 plus x whole square f double dash of x by 2 factorial plus etc. So that is the required